I'm just going to begin our AIA presentation for today. The title of the presentation is The Anatomy of a Roofing Failure. Our firm, we do a fair bit of roofing work. Matt is a registered roof consultant. I will be taking my RRC exam in a month. So something that we do a fair bit of. Before I get started, I just wanted to quickly introduce myself. My job title is Principal and Unit Manager of Copeland's office in Atlanta. My background is in structural engineering, but most of my engineering practice is in the design, investigation, and rehabilitation of building enclosures. I got my bachelor's degree at Georgia Tech in civil engineering. I'm a licensed professional engineer in Georgia, Alabama, South Carolina, North Carolina, and Tennessee. So part of our idea of setting up our offices in Atlanta is that we service the Southeast out of here. I have my registered roof observer certification with IBEC, and I will be sitting for my registered roof consultant exam a month from now. So just a little more about myself. I've managed about 100 and been part of about 110 projects across my career. I have managed about $50 million worth of construction for building envelope services. And as part of getting set up with this new job, I just set up my own personal website. There's more information about me and my projects there. But few of my projects that I've been very excited about, I worked on the Boston Museum of Fine Arts, Michigan Stadium, and last year on the Supreme Court of Georgia when they had a building envelope failure issue that I kind of got involved in to help them investigate. I do have a newsletter that I also recently started that I post on. It's like a Substack newsletter that I post on weekly, where I try to cover building envelope technical topics with very simple articles that take less than 2 minutes to read. So I will be passing out a sign-in sheet. If you would like me to add you to my newsletter, there's a little box there that you can just check. It says EE for Envelope Express. And if you need an AIA continuing education certificate for this course, there's a checkbox there as well. So just make sure you put that in, and we'll make sure that we follow up and get you either signed up for the newsletter or get you your AIA certificate. So I'll pass one on from this side and then another in this direction. Yeah, and these are the two posts that I've done so far. One was on modified bitumen membranes and how they're made, and another is the difference between a mass masonry and a veneer wall and how they function and what's the difference between them and how do you identify them. So overview for today's presentation. Firstly, I'm going to talk about why roofing failures matter. For those that are not familiar, which I don't think is anyone in this room, what is a building envelope? A quick intro to roofing, wind loads, roof drainage, identifying roofing failures, and what our options are in terms of rehabilitation once we do identify issues with our roofing systems. So let's start with why do roofing failures matter? So in terms of construction costs, roofs usually cost just 2% of our entire construction budget, but 70% of all construction related litigation is roofing related. What happens when a roof fails? So obviously we have water damage to structural components. Steel, concrete, and timber do not do well when they are exposed to water. And of course, the risk that that brings up is structural failure, which we want to avoid. Mold growth happens when water gets into the building, and that leads to a variety of health concerns for occupants of the building. And these can get pretty serious, like pneumonia or endocarditis, which is inflammation of the outer wall of your heart, can happen from mold exposure. Also, headaches, neurological issues, rashes. So from a building owner perspective, it can get pretty complicated, and obviously it's a lot of liability that owners of buildings would like to avoid. Damage to interior finishes is obviously pretty common when water gets in. Insulation gets wet, which means energy costs go up. And you also increase the risk of electrical fires when your electrical systems are exposed to water. What also happens is water from roofing failures typically migrates throughout the building. And they can be very extensive in their damage. They can be disruptive and very time consuming to investigate, expensive to repair, and they can be fairly dangerous to the occupants of the building as well, which is why they are litigated disproportionately compared to the cost that is spent on them during construction. So Architect Magazine did a kind of a investigation of all of the court cases that they could find around roofing failures, and they found about 60% of them had to do with installation and maintenance of the roof systems. 25% were attributed to design errors, and 15% were material defect related. So for those that are not familiar, or I guess for everybody, what is a building envelope? So the building envelope, as many of you know, is, I like to think of it as the skin of the building. It's what separates the conditioned indoor space from the unconditioned outdoor space. And it's the skin on all 6 sides of the building. So roofing, exterior walls, which also includes fenestration systems like doors, windows, and below grade waterproofing. And I love this photograph to kind of explain the difference. I always think of like the main wind force resisting system of the building as the bones of the structure, and the envelope as the skin that goes on top of it. So in terms of function, the building envelope is responsible for controlling the flow of water, air, heat, and vapor in and out of the building. And of course, it's also responsible for structurally being attached to the main structure of the building and performing that structural function. And the important thing is this applies to each building envelope component separately and all of them together. And we see a lot of issues happen at the transitions between wall systems and roofing systems, because that's like no man's land from a design perspective. So the building envelope, even though it may be designed and constructed by different professionals at different periods of time, needs to function as one. And that detailing and design at transitions is, and of course the installation is very, very important. So this is like my 2-step rule to where is the building envelope. If you're outside a building and you can see a building, you're looking at the building envelope. And building envelope systems can look very, very different based on the architectural style, the age of the building, the construction materials, and which face of the building that they're on. So it can be a masonry facade, stained glass, more contemporary glass facades, below grade waterproofing, stucco, low slope or steep slope roofing. They all look very different, but they're all building envelope systems. So now we move into a quick introduction to roofing. So everything happens on the roof deck. Over here, we don't have a roof deck in this photo, but what we see here are the purlins, or the structural members that support the roof deck. And over here, you see the roof deck being installed on the purlins. So roof deck materials can be varying. What I showed in the previous photo was just like a metal roof deck, but you can have structural concrete, tectum, which is cementitious wood fiber, which is basically wood fiber that is bound together with Portland cement mix. Lightweight concrete, where they use either a lot of air or lighter weight aggregates instead of stone to make the concrete lighter. Plywood, gypsum, which is like a gypsum plaster mixed with Portland cement and sand. And sometimes you even have composite decks, where it's multiple materials that are being used together to form the roof deck. In this case, it's a metal deck with steel reinforcement and structural concrete. So the performance of the roof deck from a structural perspective can be viewed from 2 different lenses. First is loading in a vertical direction. So vertical loads, like the roof deck obviously needs to sustain all of the vertical weight that is being applied to it. This can be people, mechanical systems, the actual roof system that we install on top of the deck, but also snow and rain. So anything that's on it acting downwards would be considered a vertical load. So in this visual illustration, you can kind of see it when you look at a roof. We have mechanical equipment up here, a person standing on the roof, the weight of the roof system itself are all acting downwards, and the roof deck is responsible for supporting it. And the other function of a roof deck is with lateral loads. So when you have seismic or wind loads acting on a building that are trying to push the building sideways, the roof deck performs as a diaphragm. What that means is it's part of what we call the main wind force resisting system of a building. So when wind hits the building on this side, the roof deck transmits that load into structural elements that are designed to resist that lateral load. And those structural elements are called shear walls. So they tend to be heavily reinforced, usually made out of reinforced concrete. Very often these tend to be either exterior walls or elevator shafts, which is why during like a wind-related emergency or a hurricane, you may see, instructions to take shelter in an elevator shaft because they're very significantly beefed up because they're designed to resist that lateral load. So a roof system is basically a composite system of materials secured to each other and to the roof deck, typically with adhesives and fasteners that are designed to control the flow of water, air, heat, and vapor through the building envelope. Looking at the various layers that form the roof system, we're kind of starting here at the deck, which is obviously shown here as a metal deck, but it can be a variety of materials. We have a base sheet that may or may not be required. The base sheet typically prevents water from getting into the roofing insulation from the interior of the building. This is kind of weather dependent and climate dependent. If you have a lot of interior humidity or a very high vapor drive, if you've got very cold or very hot conditions outside, you may need it. But it's kind of installed on a case-by-case basis. We have thermal insulation, which you see over here, that impedes heat transfer, a cover board that goes on top of it to protect the thermal insulation because it is compressible, and your roof membrane, which limits air, water, and vapor flow from the outside in. So I'm just going to quickly go through each layer in terms of the materials that are commonly used to fulfill those requirements. So base sheets, more often than not, are modified bitumen sheets. Modified bitumen is basically asphalt that has been blended with a polymer to give it more elastic properties. They are water repellent, vapor impermeable, and puncture resistant, so they make a great base sheet. The way that they are installed to the roof deck depends on the roof deck type. So where you have structural concrete or metal decks, typically they are peel and stick applied or torch applied. Over a metal deck, obviously the metal deck has like a profile, so you need to install an underlayment board and then install your vapor barrier to that. And they also tend to be mechanically fastened into wood, lightweight concrete, and gypsum decks. So over here you see the torch application of a base sheet. This photograph demonstrates the peel and stick. It's basically exactly how it sounds. You just take off the backing and paste it down. And this is a mechanically fastened base sheet. The insulation, more often than not, what we see is isocyanurate. It has a closed cell structure, which you see in this photograph, that prevents air and moisture movement. The thickness of how much insulation you need on your roof is defined by the International Energy Conservation Code. Depending on the state and the climate, it's typically between 5 and 6 inches. An attachment, polyiso, is either set in low-rise adhesive or it is mechanically secured, depending on the roof system overall. The cover board is either gypsum, high-density polyiso, or fiber cement boards. They are impact resistant and thermal resistant. So your polyiso insulation is compressible. If you apply too much force to it, it will kind of compress and you will lose its insulating value. So the purpose of the cover board is to protect that from happening. So the properties that we look for, and which is why these materials are selected to do the job, is that they are impact and fire resistant, and they basically protect the insulation. In conditions where we are torch applying a roof membrane, the cover board also helps protect from heat damage to the polyiso insulation below it. And typically, more often than not, you see your cover boards set on top of your polyiso with low-rise foam adhesive. Roof membranes, more often than not, are either modified bitumen or single ply, PVC, EPDM, or TPO. They are water repellent, puncture resistant, and reflective. The debate between which is better, modified bitumen or single ply, is probably a subject for a presentation on its own. But the short, like my opinion of it, is that modified bitumen membranes they have more redundancy built in the system and they are more puncture resistant, and in my experience they tend to be more durable. But single ply membranes are easier to install, they're more cost effective, but finally both are covered by warranties of the same duration. So if you're maintaining your roofs well, you can make either of them kind of get the job done. Modified bitumen membranes are typically self-adhered or torch applied. and single-ply roof systems are typically mechanically fastened or self-adhered. So this was just intended to be a very quick primer for those that are not super familiar with roofs. It's basically a sandwich that looks like this, right? You've got your deck, you've got your insulation, cover board, and roof membrane. This is the composition that you will see more often than not. And things are typically held together by mechanical fasteners or adhesives of different kinds. So now we go into wind loads. The roof system, as I said, is attached to the roof deck. And if that securement is not engineered and installed correctly, you run the risk of that roof blowing off of the building, which is what we're trying to avoid here. This diagram illustrates the way that wind acts on a roof system. So when wind is blowing over a roof system, what happens is, as it redirects up and over, it creates a suction that is pulling your roof out. And this is the failure mode that we see most often for a roofing system. Does the load act downwards in certain wind conditions? Yes, but the roof is already designed to carry that dead load and a lot of weight on top of it. So this is the failure condition that we see most often that causes roofs to fail. The code that helps us quantify wind uplift on roofs is called ASCE 7. The current edition of it is ASCE 7-22. Keeps getting updated with code cycles. ASCE 7 basically allows us or gives us engineers a step-by-step method on how to quantify that uplift that we're talking about and put numbers to it. So it does so by using environmental factors such as wind speed, which depends on the location that you're at, the terrain and surrounding topography, and the elevation of the building, as well as characteristics of that specific building, such as building height and roof geometry. So it provides us with a step-by-step process, and once we follow that, we end up with wind pressures for the different zones of the roof. So as I mentioned, when wind is blowing over a building, it causes that suction, and the suction is highest at the corners. It's next highest at the perimeters, which are shown in green, and the field of the roof has less uplift. So ASCE 7 basically shows us the different wind zones, and then it gives us a step-by-step method on how to arrive at wind pressures. So this is a quick case study from a project that it was actually the first project that I was designer of record for, so it was a pretty exciting one for me. It was the Noonday Creek Water Reclamation Facility, not far from here, maybe about 30 minutes from here. And we designed new roofs on a bunch of facility buildings that they had. Very high humidity, so it was not particularly common here, but we did have a vapor retarder over the deck. I just wanted to show you the pressures and the wind speeds that we had to design for. So we had to design for a 113 mile per hour wind. Per the code, that was the controlling number. And the pressures that we arrived at zones 1, 2, and 3. The highest pressure, zone 3, is the corner of the roof, and it was 53 PSF. Now, just to kind of create an example or help understand what 50 PSF looks like, it's a 5,000-pound elephant standing on a 10 by 10 area. So that's the volume or like the amount of force that is being exerted on a roof when you have your highest wind speed that we designed for. So we need to make sure that the engineering that goes into securing the roof system is done correctly. Because of the risk of wind uplift, the building code requires us to test roofing assemblies. So every single combination of layers needs to be tested by the roof system manufacturer. And we need to basically validate that combination of layers with the specific fastener densities and adhesive spacings, when applied with pressure, will withstand the design pressures. And this requirement for having tested assemblies is now in the building code. This photograph was taken in Arkadelphia, Arkansas. When I visited C+ manufacturing facility over there, they have a lab where they do the uplift testing. So they basically will set up a chamber like this. They'll set up the deck and all of the specific layers. And in this case, they have fans on the underside that create the uplift. And they will document the failure mode and the maximum pressure that specific roof system reaches. And they maintain a library of all of them. So on most of our projects, we don't have to do this from scratch because they have a library of all of their tested assemblies. but we need to make sure that what we are intending to put on that specific roof has been tested to meet uplift requirements. When they test it in the lab, their roof decks are obviously new because they're setting it up in the lab. But more often than not, when we remove roof systems, we reuse the existing roof deck because we don't want to get rid of that diaphragm action, and we don't want to basically destroy the structural integrity of the existing building. So how we control for that is we actually have to test the existing roof deck to see how much uplift capacity it's giving us before we install all of the new roof layers. And we do this through two methods. One is called ANSI Spry FX1, which is where we install fasteners. And Douglas, we've done this before. You install fasteners into the deck and you do a pull-out test to see what kind of resistance the roof deck is giving you. In cases where you are adhering to the roof deck, you can use another test method, which is IA1, which is an adhesion pull test. Essentially, what you're saying is we don't have the same deck that we did in the lab, so let's just go out there and test the roof deck in the field to confirm that it's giving us the same uplift resistance that we need to confirm that the roof deck is not going to fail. Now, if the roof deck doesn't have sufficient capacity, it needs to be removed or replaced, and we need to test it again to make sure that it has enough capacity before we move forward. As I mentioned earlier, the pressures are highest at the perimeters and corners of a roof, and usually the perimeter conditions tend to fail first. Now, when I say perimeter conditions, I am referring to gutters, copings, and drip edges. So the building code also now requires us to perform testing per two standards, ANSI Spry ES1 for drip edges and copings, and ANSI Spry GT1 for gutters, where these assemblies need to be constructed in the lab and tested. So over here, you can see this rig is testing the coping for upward pressure. And we need to select assemblies that have already been tested in the lab to show that they meet or exceed the pressure requirements for the project per ASCE 7. So the next chapter that I have covers roof drainage fundamentals. Roof drainage is very important because the structural deck is designed to hold a maximum of 4 inches of standing water. If you have more water than that build up, you stand a very real risk of the whole roof deck collapsing with all of that water, which is a tremendous amount of weight. And obviously that's extremely dangerous to the occupants of the building. And over and above that, you obviously have water damage because you have all of that water getting into your interior spaces. And we want to make sure that that is avoided. All roofs, I wouldn't say all, roofs should be designed to drain, right? So over here, what you see is a flat roof deck made out of metal. And we have created a slope using insulation to direct water towards roof drainage mechanisms. The code requires a slope of 1/4 inch per foot at the minimum. But sometimes when we work on older buildings that were built to meet the current code requirements of the time, it may be different. And we need to upgrade the taper in the roof. There are two ways that we can achieve a roof slope. One is by sloping the roof deck itself. Very often that will be the case when we have a metal deck. But if we have a flat deck, and whatever material it is, we achieve the slope using tapered insulation. The most commonly used roof drainage mechanisms are internal roof drains, which are exactly what they sound like. You would have seen them on roofs. They just drain bowls that connect to piping that leads the water into a stormwater drainage system. We have scuppers, which are little holes in your parapet walls that take water off of the roof. And we have gutters and downspouts. As building envelope consultants, when we do roof design, we design each roof to drain, right? So we prepare what's called a roof drainage plan. And this is part of our new roof plan typically. Over here, you'll see this is the ridge of the roof. We have it sloping this way and that way. And these blue arrows kind of indicate the path that water is taking. We have drains at these locations. And we use these things called crickets to direct water in more specific areas. And the crickets will typically have a slope that is twice the slope of the roof. So now we have kind of looking at the concept of overflow drainage. There are situations in which your primary roof drainage system may fail. Now, for all new buildings, the code requires that we have a secondary drainage system that is there basically as a fail-safe. And that secondary drainage system needs to be set between 2 and 4 inches higher than the primary drainage system to make sure that you have no water build up more than 4 inches. And this can be achieved in a bunch of different ways. So over here, we have 2 drain bowls side by side. This drain is set 2 inches to 4 inches upslope. So if you have water ponding, it's not going to build up on your roof beyond 4 inches. Gutters obviously kind of have like a self-built overflow drainage system, which is you will have a waterfall, whether you like it or not. And sometimes you will also see this configuration where you have a scupper set close to a primary roof drain. So if you have water building up, it's going to be able to get off of the roof. Now, many times when we work on existing buildings, they don't have overflow drainage systems. As roof consultants, we like to install them, but there may be times where the client does not have the budget or they may not choose to. And the code has an exception that if you are re-roofing an existing building, you do not have to install overflow drainage system. So if the budget doesn't allow for it, or the client is very keen that they don't want to install it for whatever reason, you can use that exception in the code to bypass that requirement. So as consultants, we also have to run calculations to kind of determine that the roof is able to drain the volume of water that is hitting it. Typically, we design for a 100-year hourly rainfall rate, which means it is a rain event that is likely to occur once in every 100 years. Or another way of looking at it is there's a 1% chance of a rain event that heavy happening this year. We get this data, it's meteorological data that is built into the plumbing code, and we use that. So that combined with the size of the roof area and using a basic formula, you get your total volume of water that is going to accumulate on your roof. We divide that up by the number of roof drains or scuppers or gutters or whatever you have draining your roof. And then we refer to standards in the International Plumbing Code or other industry standards to figure out the appropriate sizing for the drainage mechanism that we're using. So the next chapter that I have is identifying roofing failures. So these are the way that okay, so none of my photographs for this slide seem to be loading. That's fine. Oh, there we go. These are common symptoms of a roof system deteriorating. One is excessive granule migration. So modified bitumen roof membranes have granules embedded in the top surface to make them reflective. So they don't absorb a lot of sunlight and heat up the building on the inside. As a roof system ages, seeing excessive granule migration is an indication that the roof system has aged, and it could indicate potential like deterioration of the roof system. But it may or may not. It needs to be kind of investigated further on a case-by-case basis. Blistering is certainly a sign that the roof system has been compromised, because what happens is when water gets underneath your roof membrane and then that roof membrane heats up with the sun, that water will turn into steam and it will push up against the roof membrane. So you'll see bubbles or blisters in the surface of the roof, which is an indication that your insulation on the inside is wet. So that certainly indicates an issue. Alligator cracking is what it sounds like. The roof system or the membrane will deteriorate in a way that resembles alligator skin. And this typically happens because of UV degradation. If the modified bitumen blend is formulated well, this shouldn't happen, but we do see it from time to time. Hail damage will create what we call spotting, which kind of causes surface level damage to the roof membrane. It may or may not be an issue. In this case, modified bitumen membranes, especially dual reinforced modified bitumen membranes, do a much better job of resisting that hail impact than single ply membranes, because single ply is just one thin sheet of plastic with a reinforcement. And when I was at the C+ plant, I got to see how they test roof assemblies for hail. They basically will make an ice cube and they put it into a cannon and they fire it at the roof system. So it's fun to watch, but I'm sure it's not as fun when you own the building. So other signs of deterioration, single ply membranes can become brittle and flake over a period of time from excessive exposure to sunlight. Ponding water is an indication that your roof is not draining properly. This can be due to a variety of reasons. Sometimes when your insulation is wet and it gets compressed, you can lose your taper. Sometimes the roof deck will start to sag. And so there are a variety of reasons where you can lose your positive roof drainage. Laps opening up, you don't want to see that because it creates the opportunity for bulk water to enter the interior of your building. And the next few are kind of symptoms that I have noticed from experience of just investigating buildings. It's people trying to fix problems. It tells you that there's something wrong. So whenever you see a scupper or a gutter that has been sealed off, chances are they're having issues and the maintenance person has come out and tried to do something. So you know that water is getting into the inside of the building. Similarly, where you have a lot of random coatings applied to a roofing system, it's a sign that something is wrong. Where you have sealant, sealant is a dead giveaway that something is wrong, because the moment water is getting in, the first line of attack is always a guy with a sealant gun. And if that hasn't worked for 10 times, that's when you will get involved as a designer. So whenever I see sealant, I know there's an issue. Typically, it's around penetration details, where you have pipes or metal components going through the roof system. Sometimes you'll see it around drains, around scuppers. Those are your usual suspects as far as details that are sealant reinforced. Stained ceiling tiles, I see this a fair bit. And finally, if you see a bucket, you know that it's leaking. And they have a lot of very fancy versions of this. They have these things that I've now started to see at a lot of schools where it's a replacement for a ceiling tile that basically catches water and then drains it into a bucket. So these are basically signs that the roof system is failing, and you can kind of quickly pick up what's going on. As far as lifespans of roofing systems go, this is also kind of like a hotly debated topic. And I don't think there's a single right answer. But generally speaking, single ply roofing systems tend to last between 15 and 20 years, and modified bitumen systems tend to last between 25 and 30 years. But there's a huge asterisk here. This is not like a blanket rule, kind of varies on a case by case basis. And we'll look into some of those details, I guess. Personally, I have seen modified bitumen roof systems that have been maintained well and consistently, that have lasted perfectly well up to the 40-year mark. And at the end of the roof's life, typically what happens is it will need to be replaced. And that involves removing all of those layers that I showed you earlier down to the roof deck and installing new insulation, new cover board, and a new roofing membrane. So if you end up on a job site, either as an owner or as a client or as someone who's working on the building, and you see issues with your existing roof system, what options do you have? The first thing, and the way that I've organized this is in order of cost, because acting early saves you money. And repairing damage as soon as you see it is always the cheapest way to go in the long term. The first thing that I would do is check if your roof system is still under warranty. Typically, both single ply and mod bit roofs have a 20-year warranty. And this also applies for metal roofing, commercial, even if you have like asphalt shingles, they have 20-year warranties. The installer will have a 1-year workmanship warranty. So for the first year after you've installed a new roof, you can just call up your roof contractor and be like, hey, I'm having a leak. Please come out and fix it. And ideally, they should do that for you. But once it goes beyond that, it kind of becomes the responsibility of the roof system manufacturer. And more often than not, if your roof is under warranty and you bring up the issues to the roof system manufacturer, they'll have someone come out, inspect it, figure out how to repair it, and the costs of those repairs will be covered within your warranty. And as you can see, a 20-year warranty covers this a significant part of your roof's lifespan. So you doing your periodic inspections every quarter or every 6 months can save you a lot of money in the long term, because you can identify issues and bring on someone who can help repair those problems proactively. If your roof is not under warranty, the next cheapest thing you can do is to pay a contractor to come out and investigate the issue and repair it before it starts to progress. Catching issues early, repairing them often, and avoiding replacements is the way that you want to go. Roof replacements tend to be very, very expensive. So the longer that you can push those out in the life cycle of your building, the better it is for you. Now, the next option that you have is a roof recover. So if we have a roof that is like 20 years or 25 years old, and the roof membrane has deteriorated, and all of the flashings are deteriorating, and we need to do something about it, a roof recover basically allows us an option to install a new cover board and a new roof membrane over an existing roof. And that can extend the lifespan by another 15 or 20 years. It is much more cost effective than replacing your roof as a whole. So over here, you'll see your typical roof sandwich with your roof deck, insulation, cover board, and membrane. Essentially, what we do is come back with a new cover board and a new roofing membrane. And when you look at it standing on the roof, it looks like a brand new roof. All of your flashings are brand new, but you are retaining the insulation and the existing cover board, and that saves a lot of money. You also are not demolishing the existing roof system, so you don't have to deal with all of that construction debris, which saves a lot of money. And you are not really exposing the roof deck, and you don't have the risk of bulk water entering your building. Especially in Georgia, we have like pop-up storms that will show up in the afternoon that no weather app can tell you about. And all of the contractors that I've worked with are like, we can't predict the weather. We can do what we can to protect, but chances are during your roof replacement project, if it's a 3 or 4 month construction duration, you may have at least 1 or 2 events where water gets in, and the best they can do is just clean up after themselves. So it saves a lot of money, and it extends the lifespan of your roof without having to do a full replacement. But the big thing that you need to do before you do a roof recover is an infrared scan of the roof. So what they do is basically fly a drone over the roof, and you can identify areas of thermal anomalies. When water gets into your insulation, it's no longer doing what it should. It is, say, if we go in the evening and the sun has just set, the insulation will not be as hot as the water that is trapped within that roof, because water holds that heat. So if you come, like say after dark, and you fly a drone, the areas of your insulation that are saturated with water will show up as much warmer on your IR scan, and you will know that your insulation is wet. The big caveat with a roof recover is that all areas of wet insulation need to be cut open, and that insulation needs to be removed and replaced with new insulation. And the cutoff that we have for that, which is kind of an industry standard, is 15%. So if you have done a good job of maintaining your roof over those 20 or 25 years, and you have mitigated the amount of water getting into that system and saturating the roof insulation, it puts you in a good position to be able to do a roof recover instead of a replacement, and that saves you a lot of money in the long term. And this kind of comes back to my point that I was making earlier, that proactive maintenance when it comes to roofing systems saves a lot of money in the long run. Finally, and this is something that you can't avoid in the life cycle of a roof, is a replacement. Roof replacements involve removing all of your roofing layers, your membrane, all of the flashings, your cover board, your insulation, down to the roof deck, and installing a brand new everything. Now, the building code allows you to have only 2 roofs on a building at any given time. So what that means is if you have one existing roof and you recover it once, you can't recover it more than that. You can't do a second recover. So at that point, you will have to remove your roof system, your roof recover, down to the roof deck, and then install a brand new system. Over here as well, maintaining your roof system well will save you a lot of money, because as water gets into your roof system, it not only damages your insulation, but it also damages the structural components underneath and the roof deck. So if we have to do a roof replacement and we remove all of the insulation and all of the layers down to the deck, if the building management has kind of turned a blind eye to roof leaks, you can have extensive deterioration of your roof deck. And that deterioration is something that we will need to address, because we will not have sufficient uplift capacity in the deck when we do our testing. So we will have to maybe replace large sections of the deck. So if you're not proactively maintaining your roofs, roof replacements can become much more expensive, because they become a structural problem as much as they are a building enclosure problem. Now, one thing that I like to say pretty often is that having a quality assurance observer on a job during a roof replacement project is a great idea, because most of the roof is buried once you're done, and when you're walking on it, you don't know how it was installed. And having someone who is like a third party set of eyes kind of review things, verify against the construction documents, and notify the contractor saying, hey, the specs say this or the drawings say this, maybe we should do this differently or not, and documenting the installation of all of those layers helps a lot from the long run, because it, more than anything, it assists the contractor in making sure that they're able to meet the requirements of the roof system. Also, in a world where roofing is so heavily litigated, having documentation of your roof system installation can be very helpful if push comes to shove and you end up in some kind of legal situation around it. Now, one thing that I will say about roof replacements is that when you're opening up an existing roof system, you never know what you'll find. This is something that I saw on a public school that I worked on, where we had designed this roof system thinking it was a metal deck through and through. And we had performed isolated core cuts across the roof area to determine what the composition of the system was. But we noticed that they had a small area that had a tectum deck. So unforeseen conditions are pretty common when you remove an existing roof. And at that point, you will have to design as you go, and the contractor will submit an RFI and you work with them to update your design as is needed. That being said, once a roof replacement project is complete, it looks stunning. This is one of the first projects that I worked on while I kind of entered a project management role at Raymond. This is the Campbell Middle School with Cobb County. And it was, I think, $120,000 roof replacement. It looks like a single ply roof, but it's actually mod bit. The installers did a phenomenal job. Yeah, and since then I've done a lot of work for the school district. Just the satisfaction that you see when your project has kind of reached completion is unmatched. Of late, we've been using this new software tool called NearMap, where they fly aircrafts across buildings and document, especially urban areas, in very, very high resolution. And they have a way that you can kind of adjust for time. So you can see the same building now 6 months before, a year before, or 2 years before. And when you see the before and after shots of a roof replacement or a recover project, and you see what you have done to improve the building, it's a very fulfilling thing. So I'm almost done with my presentation. But before I kind of wind up, what I will say is and I'll take any questions that you guys have, and we're a small group, so we can just chat about stuff. We will take a quick break between 1 and 1:15. We are very grateful that Tariq from the Georgia Tech High Performance Building Lab is with us today. So he's worked on an amazing software tool. It's basically like a drone deployed diagnostic tool for buildings. Absolutely cutting edge stuff. So we're very grateful that he was able to take the time and join us today. So he will be presenting on that between 1:15 and 1:40, including question and answers. Feel free to ask him any questions that you have. And before I wind up, I also want to kind of let you guys know that we are in kind of a mode where we're trying to get set up and established, and we're trying to make as many connections as possible. And we do offer AIA continuing education courses at any organization's office. Like, we're very happy to travel to do that. We'll be speaking at Emory this week. We'll be speaking at HKS Architects next week. We'll be at Page tomorrow. So we're trying to make a very active effort to kind of put ourselves out there and introduce ourselves to various stakeholders. And we have, of course, this roofing continuing education workshop, but we can also custom build whatever that specific team is interested in. So for UGA, for example, we will be setting up a whole building airtightness training for them. So just keep us in mind. You know, if you have very strong industry connections with any specific building owners, we would be very happy to set that up. If you think it would be beneficial for us to present together, we would be very, very happy to do that. So please do let me know and we can set things up. And secondly, I also just kind of wanted to put the word out, since we have so many people in our industry here. We are starting to look at growing our team in Atlanta. So we are going to try to hire someone at a technical lead level, hopefully like a licensed professional, either an architect or an engineer, to like run projects. But we are also trying to hire consultant level staff that will, say, at an EIT level, or maybe 3 to 5 years of work experience, to kind of join our team as well. So if you come across anyone that you think will be a good fit, please do connect them with me. We try to have a positive work environment, support everyone that we work with. So far, I've completely loved being part of Raymond. The company culture that Matt and Chelsea and the team have set up is amazing, and we're definitely looking to grow that in Atlanta. So if you find people that, in terms of mindset and personality, are a good fit, please feel free to connect me. And finally, we have about 7 minutes or so before we take a break. So if you guys have any questions, not just questions, I know that there are a lot of people here with a lot of expertise from different sides of our industry. So if you have something to add, because my presentation was kind of a very high level overview of things, any experiences that you've had that you'd like to share, now would be a great time. Yeah.
So you say you can do the re-roofing, right? Like
Uh-huh.
basically just existing roof, and then you just put a new cover board and then a new like roof membrane on top of that. So you say doing that, but you didn't say do you need to take off the old ones and then basically replace the old cover board and then roof membrane, or you just put the new cover board and then the new roof membrane on top of the old membrane? Do you need to take them off first and then replace the new ones?
No. So when you're doing a roof recover, you may need to clean the existing roof system a little bit to make sure that your new layers can bond properly, but you leave the existing roof system exactly as it is.
Oh, okay.
Yeah. So sometimes, go ahead. Absolutely. To kind of vent it out and let that moisture. Yeah. Yep. Yeah. Yeah. So to answer that question, basically you can leave it in place. Yeah. Any other questions, comments? No, doesn't seem like it. So in that case, what we can do is maybe we can take our break just a little early. The restrooms are across these double doors, and you will need key card access. So I'll kind of hang out around there and let you go back and forth. And maybe we can start a little earlier so that we can kind of give you guys back some of your time during the day.